Sometimes we need to know about the relevance to monitor the different historical episodes that happened in the past on environmental historical pattern. The temporary series help us to know what happened in the past in relationship with different variables such as fauna, flora, ecology, hydrology, forest fire, glacial, temperature, precipitation, and other variables more. But we need to know how accomplish this, how make a temporary series. What is the process to accomplish this? Thanks. In this time, I'll share you how make a three-ring chronology, a temporary series from three-ring width. I'll explain you what is the process to make this, what statistical method we need to make this temporary series. In this case, we need to work with DplR package in an R statistical software. When we'll achieve our temporary series or our three-ring chronology, we can correlate this timeline with other variables and know how was or how were this relationship with this different variable of interest. How were the relationship from this three-ring chronology with fauna, flora, glacial, forest fire, hydrology, temperature, precipitation, carbon, and other variables. Who were the relationship? And we can contribute with different environmental measures that help our planet. In these regards, we need to remember what we need to accomplish this. So we need collect our sample, collect our different codes in field. We need after make the measure in a stereo microscope, a specialist stereo microscope from maybe LINCTAF and others. After, when we are measure, we need to load up our data in our statistical software. After, we need to make different codes or logarithms to accomplish this in our statistical software. Let's go. I'll share you my screen. Okay, I'll share you my screen. Firstly, we need the main library to work in this process. The principal library are XL is X, DplR package, ggplot, Gray, XL is, and utils package. We need to run this, and it's necessary now that all libraries are in this space, in our environment space. We can see that our data is recognized. The following step is process our data, read our data. Our data is from Peru, from Fike Forest. Things we need to run this. We can see that our data is recognized too with 51 variables and 66 observation. We can see this. We can see that our data have years calls and all our core 1952 years until 2017 with 66 years and 50 variables. Okay, we need to follow in our process. After, we need to give the correct format. We need to run this. Go about this. The format refers that firstly, all years are in the following column, and in this case, the years columns occupy this place now. And in this place are only the core sample, all the measurement that we did. Okay. How we data were in micras, in micrometric data, we need to cross to millimeter data. Things we need to run this, and we can see the chain. The firstly, our data were in micrometric format, and now our data is a millimeter format. We can follow in the next stage. In this time, we need to explore our data and about the series. We need to run. We have 66 years and 50 variables or series. This is about cores. In the DplR package, we have a spaghetti plot function. With this, we can see that all sample data or core data with our measure that we did before, with this spaghetti plot function, we can see that all data is fixed since the small series, medium series, and big series with its coded. The DplR package have this function, the report and summarize. Things we need to run and see how is. Things this report about number of data series is 50. Number of measurements is 23, 24. The average series length is 46.48. The range of years is 66. The spans refers to the years, the 90, 52, and 2017. The standard deviation series intercorrelation is about the 0.46, and the autocorrelation in order 1 is 0.24. The others summarize that we have is about the all of series, the first years, the last years, the total years, the means, medians, standard deviation, and autocorrelation. Okay, the cross-dating. The cross-dating refers about how is the correlation in this series. How all our series are correlated between series. Following the leave one out principles or criteria, things we can see when we are running this, we can see our graphic. Things. The optimus is that when is the blue color is a good correlation, the red color is no good correlation. In the green color, there are no correlation. The correct is that when you are working with your data, if your measurements is very well, all these color will be blue color. A little part a red color. We read the correlation. In this case, this DplR package also apply the Spearman correlation too. We can see the results. We have high correlation, and other we have a small correlation, very, very small correlation. This is the results in this stage, but the necessary and important is that we have a high correlation. Okay, can I make a chronology with all age groups? In this case, we can correlate it about by age segments. We need to run this, and we can see our correlation is the 0.48 correlation in the same case. The next step is about standardization. Once we have read the data and we see that the series always cross-dated, we need to eliminate the trends of the series that are not associated with the weather. That is the trend of age, contamination, or disturbance associated with forest management, etc. We can start by making a chronology with the spline method. If we put n years equal null, the spline will be 0.67 of the length of each series. Thanks, in this case, we use the trend function we can see, but in this process, we apply the spline function, the spline methods that offer the trending with years 50, make it plot through, frequency the 0.5, and we can choose if we want to make graphics. We need to run this, and we have a lot of spline of all our series. Things when we are speak about the train method, this is the results. All our series is for in only one series. In this case, we can remember that when we are applying the trending methods, we are eliminating all different tendencies that are affected by topography, contamination, perturbation, anthropic action, and others. Sensitivity and GLK. When we are speaking about sensitive, we are referred that how is the sensitivity in a growth tree? How our tree grow? If tree grow in a high topography, this affect the growth from our tree because our tree feeling a different type of stress, and all these perturbations are registering inside of the tree. So with this sensitive statistical result, we can know how is the growth about all tree. The GLK is the same for how is the growth on all tree. In the next stage, all series crossway with each other. Things we need to run this code. And after, we need to read, follow the citric core norm. When we are speaking about citric core, this explains that the site represents the site or our data was collected. The tree, how many trees we collect our cores. In core, what number we use for identify each core. Things is necessary in the first stage level in a correct for all samples. In Excel or CSV format in the first stage, because only if our data are very well labeled, when we are using the DplR package in our statistical software, all our data will be called. This is the importance. Follow the STC norm. In this case, we need to calculate the summary statistic on the trending ringwood series. Our data refers about the number of the cores, 50, the number of the tree, 26. The R bar refers the correlation between series, the correlation between tree, and EPS value. The EPS represent the expressive population signal. This is very important. This statistical result is very important because with this data, we will know how will be our tree chronology, the quality of our tree chronology. With this statistical parameter, EP is express population signal. Things is necessary to know that the trends offers different methods. Splines, most negative exponential. In the next stage, we run the most negative exponential function is the trending method 2. The first, I use the spline method from the trending. In this case, I use most negative exponential methods that offer the trending. Things when we are running all these the trending method, when we calculated the EPS, I can see the difference. If with a spline or with most negative exponential is better, I will see in this place, in EPS value. In the same case, we are working with the spline and most negative exponential method that offer the trending. In the next point, we made the plot. If we have set priority true, the standardized one will remain at the top and the residual one at the bottom. We also include the number of the sample in time. Thanks, this is the final action that we need to make in this case, in this process. In this case, we need to put the color that we want in our tree chronology, the years about the splines, the colors in the calls, the colors in the sample depth, in the labels, in the literal, in different forms that we want that have our tree chronology. Things we accomplish this. We have our tree chronology in this case. This is a temporary series from tree. Things we can correlate this tree chronology with different variables of interest and know how are related with other variables such as fauna, flora, hydrology, temperature, precipitation, carbon, glacial, forest fire, ecology, and different variables that we need to know how is related and how we can contribute with different environmental measures that help our planet.